Hello my scholars, this is my school channel where we are tackling the JAMB CBT past question for the subject Physics the year 2017. In this clip we'll be solving questions 16 to 30. So join me as we tackle question 16. Calculate the height of the image formed by a pinhole camera of length 12 cm used to photograph an object 60 cm away from the hole and 70 cm high. Okay, this is so easy to tackle. So let's just go to our whiteboard so that we can provide solution to this question. All right, so we'll have the magnification first as the length of the pinhole camera, which we are given as 12 cm over the object distance away from the hole, and that is 60 cm. And 1 divided by 5 gives us 0.2. So we'll recall that also magnification equals the image height or the image distance over object height or object distance. So whatever you are using is just image over height, okay? So we are asked to find the image height from the question, or the height of the image. So that will be I over the object distance. We are told that the object is 70 cm high, okay, and that is 70. Already we have gotten a magnification as 0.2. So we would have 0.2 equals the image height over the object height, which is 70. So by the time we cross multiply, we would have the image height equals 70 times 0.2, okay, and that gives us 14 centimeter. So all we just have to do is to go back to our screen and select out the correct option. Looking through all of the options together, we would confirm that option D for 14 centimeter is the correct option. Question 17. When two objects P and Q are supplied with the same quantity of heat, okay, the temperature change in P is observed to be twice that of Q. The mass of P is half that of Q. The ratio of the specific heat capacity of P to Q is what? Okay, so the first thing we did was to pull out all of the values for P and Q, giving a mathematical interpretation to the question. So we have the quantity of heat supplied is the same in P and Q. The temperature is twice that of what we have. Then the mass, we are told that the mass of P is half that of Q. So finding their ratios of specific heat capacity, since this is already the same thing, so we'll just have, all right, for P, we just have 1, right, times the mass as still 1 over, okay, for when the temperature is 2, okay, when temperature is 1 here, it is 2 for Q. So for temperature we have 2 times, when the mass of P is 1, the temperature here is half. Okay, to be more detailed, I'll just have to include the heat content. Okay, so we have the heat supplied in P is 1, and what is supplied in Q is still 1. Okay, so let's do this. We have 2 here, 1, 2 here, 1. So practically we have 1 times 1, that is 1 times 1, that is 1 over, for the denominator we have 1 times 1, 1 times 1, that is 1. So we have 1 ratio 1. So we just have to go right there and select the correct option. Scanning through them all will confirm that option C is correct, 1 ratio 1. Down to question 18. When the RMS value of a source of electricity supply is given as 240 volts, it means that the peak value of the supply is what? Okay, so peak value equals √2 times the VRMS. Okay, that's very easy to do. This is for peak value, and this is for the RMS, okay, times √2. So from the question, we have our VRMS as 240 volts times root 2. Okay, what we'll be having is 339 point some other figures like that. So we can round this up or approximate it to 340 volts. So we have to just go back to our screen and select the correct option. So when we look at option B, it tallies with what we have on our whiteboard, so we can confidently say that option B is the correct option. Question 19. Which of the following operations can be used to convert an alternating current dynamo into a direct current dynamo? Okay, so when you examine the features or what you can find in an alternative current dynamo, you will find two copper slip rings. Okay, so converting it to a direct current dynamo, all you just have to do is to convert these two slip rings. Okay, you replace it with a single split ring rather, or a commutator, just like in electric motor. So the correct option here is changing these two copper slip rings, okay, to a single split ring or commutator. All right, so like I said, option C is super correct. I believe it's very important for me to remind you that you can get any of the Myschool tools to help you better prepare for your coming exams. All you just have to do, click on the link in the description below. It takes you to the Myschool website where you have enough guidelines on how you can get the Myschool mobile app or the Myschool software. So right there we are tackling question 20. The net capacitance in the circuit above is what? Okay, looking at this arrangement, this is a parallel arrangement. Bringing them together, we are going to join it along with this as a serial arrangement or arrangement in series. So join me as we tackle question 20. So at first, we'll recall that arrangements in parallel for capacitance, okay, that will just give us 2 plus 2. These are the ones we have in parallel arrangement, and that equals 4 microfarad. Okay, join me to the other one we have. That's going to form an arrangement in series. Okay, and that arrangement in series equals this 1/4 plus the other one we already have, that is 1/4. So we have our LCM as 4. All right, 4 in 4, that is 1 times 1. We have 1. We drop down the plus sign. 4 in 4, that is 1 times 1. We have 1, that equals 2/4 or 1/2. So arrangement in series for capacitance equals 1/C equals 1/2. As we cross multiply, we would have 2 times 1 equals C times 1, and that is C equals 2. Okay, 2 microfarad. All right, let's go back to the screen and select the correct option. So you agree with me that option D for 2.0 microfarad is the correct option. Kindly remember that you have to hit the like button, click on the subscribe button, and tap on bell notifications so you can get alerts as soon as the next video is uploaded. Number 21. The instrument used to measure the pressure of a gas is what? Okay, so a barometer, we use barometer to measure atmospheric pressure. We use thermometer to measure temperature. We use hydrometer to measure relative density of liquid depending on the concept of buoyancy. Okay, and then we use manometer to indicate and measure pressure. So the most viable option to this question given is option D for manometer. Question 22. A man of mass 50 kg ascends a flight of stairs, okay, 5 meters high in 5 seconds. If acceleration due to gravity is 10 meters per second square, okay, the power expended is what? Remember that power equals work done over time taken, and work done is still force times distance, okay, still over time. Okay, so, and we'll recall that the formula for force is mass times acceleration due to gravity because it's ascending flight of stairs. Okay, so that means the formula for power will be equals to work done over time taken, okay, where work done is force times the distance, okay, over time taken, and force is mass times acceleration due to gravity times the distance or the height in this context, okay, over time. So we have a mass, according to the question, 50 kg. That's 50 times acceleration due to gravity, that is 10, okay, times the height, okay, and the height is 5, over the time taken, which is 5 seconds. So 50 times 100, that is 500 watts units for power. Okay, so we just have to go back to our screen and select the correct option, 500 watts. So we can see that option D is correct. Question 23. A radio station broadcasts at a frequency of 600 kilohertz, okay? If the speed of light in air is 3 times 10 raised to power 8 meter per second, okay, calculate the wavelength of the radio wave. Okay, so we should just recall that V equals F lambda, okay, where the F stands for the frequency and the lambda stands for the wavelength. So CT equals to frequency. All right, so we are asked to find the wavelength, so that will be divided by F, divided by F. Okay, so we have wavelength equals V over F. Okay, and we have the speed here as 3 times 10 raised to power 8. Okay, over the frequency is 600 kilowatts. Okay, that will be 600 times 10. Kilo is 10 raised to power 3. Isn't it? All right, so if I want to simplify this further, I will just say 3 times 10 raised to power 8, okay, over, if I want to convert this to standard form, this 600, it still means 6 times 10 raised to power 2 times 10 raised to power 3, okay, these 2 zeros here, and this for the kilo. Very well, so I would have 3 over 6 times 10 raised to power 8 minus, what we have in the denominator is 2 and 3. So 2 plus 3, that is 5. Okay. This divide means minus, and that's what we have here. So that will be 10 raised to power 8 minus 5. 3 here 1, 3 here 2. So I have 1 over 2 times 10 raised to power 3. 1 over 2 is still 0.5. That is 0.5 times 10 raised to power 3. Okay. So that still means 0.5 times 1000. 10 raised to power 3, that is 10 times 10, that is 100 times 10, that is 1000. So 0.5 times 1000, that is 500. So the correct answer is 500 for the wavelength, okay? And that is measured in meters. So let's go back to the screen and select the correct option. So option B is correct. That is 500, or 5.0 times 10 raised to power 2 meters. So option B is the correct option. Question 24. Which of the following is a scalar quantity? Okay, so we know scalar quantities, they have magnitude but no direction. On the contrary, we have vector quantities, they have magnitude and direction as well. So going through all of these options, the scalar quantity that we have here is mass. That is option D. Option D is the correct option. Please remember that nothing stops you from asking your questions right away. All you just have to do, click on the link in the description below. It takes you to the Myschool website, where we have a handful of solution providers waiting to help you out. So why not ask your questions right now? We are tackling question 25. Determine the focal length of a thin converging lens if the power is 5.0 diopters. Diopters is the unit to measure the refractive power of a lens, rather. Okay, so let's go to our working board so that we can give answer to this question. So recall that this power equals the 1 over the focal length. Okay, so we are asked to find focal length. All right, so what do we do first? We cross multiply. That will be, okay, times focal length equals 1. So we divide both sides by this, the power in diopters. So that means focal length equals 1 over this power in diopters, and the value given is 5. So 1 divided by 5 is 0.2. Okay, so in meters. So let's go to the screen and pick out the correct option. So look through it and you will validate option B. Okay, option B is the correct option. So if you have better steps or explanations to any of the questions we have tackled so far, please, we would like to know. Kindly use the comment section below, indicate the question number and the solutions you would like to share. Question 26. A string of length 5 centimeters is extended by 0.04 meters, okay, when a load of 0.8 kg is suspended at its end. How far will it extend if a force of 16 Newton is applied? All right, so there are different ways to solve this question, but I'm just going to use the easier step. Okay, so we can deduct from the question that an extension of 0.04 meters is being produced when a load of 0.8 kg is applied. Okay, so converting this 0.8 kg to Newton, that would just be roughly by times 10, okay, and that gives you 8 Newton. So that implies that 8 Newton will give us 0.04, okay. So 16 Newton is just times 2 of 8 Newton. So if 8 Newton is giving us 0.04 extension, therefore 16 units, which is times 2 of 8 Newton, will give us times 2 of that extension. So that will just be 2 times 0.04, and that is 0.08. Remember, there are other methods we can use using F equals to KE. Okay, that is Hooke's law. But this method is very simple, easy, and direct. So the correct option to this question is option D, 0.08 meters. Number 27. How can energy loss be minimized through eddy current? Okay, so looking at this concept presented to us, the best that we can use based on the context of options given is that we can refer to using high resistance wire, okay, or laminating, okay, or by lamination. Okay, this will introduce a kind of cut, all right, and create gaps which this eddy current cannot flow through this gap. So the most viable option here is option A, by using high resistance wire. Question 28. From the diagram above, okay, calculate the energy stored in the capacitor, and we'll recall that the energy stored in a capacitor equals half CV squared, where C is for the value of the capacitor that we have there, and V is for voltage. Okay, so that is half CV squared. Okay, that will be half times the C, which is 8 microfarad from the question, as 8 times 10 raised to power minus 6. Okay, then times the V is 10, voltage is 10 raised to power 2. Very well, so we have 2 here 1, 2 here 4, so we have 4 times 10 raised to power minus 6. All right, this changes to plus, so minus 6 plus 2, that is minus 4. 4 times 10 raised to power minus 4. So let's go back to our options and select the right answer. We would see that option B, 4.0 times 10 raised to power minus 4 joule, is the correct option. 29. A constant force of 5 Newton acts for 5 seconds on a mass of 5 kilogram initially at rest. Calculate the final momentum. Okay, so we recall that impulse equals change in momentum. That is Ft equals the change in momentum. Okay, or you can have it as m into bracket v minus u, whatever thing we want to use. So let's stick to this. So we'll have our force is 5 Newton, okay, times the time given, that is 5 seconds, equals mv, all right, minus mu. We are given this information from the question that it's initially at rest, and that implicates 0. So 0 times m, that is 0. So we just have mv which represents our final momentum. So our final momentum equals 5 times 5. Therefore, our final momentum is 25. So let's go back to the screen and pick out the correct option. The correct option is option B, 25 kilogram meter per second. So option B is super correct. 30. Refraction, interference, diffraction. Which of the above properties are common to all waves? Okay. The first thing to do is just to remember the properties of waves, and they include, some of them include reflection, refraction, interference, diffraction. So going back to the context of the question we are given, so we've just mentioned refraction, interference, and diffraction. So all of these properties are common to waves. Okay, so the most viable option here is option B, 1, 2, and 3. Roman figure 1, 2, and 3. We believe you enjoyed this content and you like us to bring you more. All you just have to do is to hit the like button, click on the subscribe button, and tap on bell notifications so you can get informed as soon as the next videos are released.